Hey everyone, hope you enjoyed the first video, which started to introduce us to working in the 3D coordinate plane. In this video, it's a short one. We're just going to talk about one idea, and that is how do you get the equation of a plane if you know three non-collinear points, which hopefully you remember this from geometry. I'll just actually put a quick page in here. If you wanted to find a plane, if a plane was defined as being three non-collinear points. So 3 points that are not all in the same line. So if we want to be able to write the equation of this plane, we need 3 non-collinear points. So that's what we're going to do today. What if we have these 3 points? How do we get the equation ax plus by plus cz equals d? How do we get this equation of the plane? That's what we're looking for. Okay, so first of all, we're going to be given our 3 points. And we're going to substitute them in for x, y, and z in this equation. And we're going to create 3 new equations. The only problem with that is we end up with 4 unknowns, a, b, c, and d. I'll come back up to the top in a second after I show this part. So let me do this. I'm actually going to get rid of that, and we'll do it together. So here's what I mean. I'll come back up to the explanation in a minute. So let's say we're given these 3 points, P, Q, and R, and we want to, they're non-collinear, which we could check, but they're definitely not on the same line. And we want to create a plane with them. Okay, so the first thing that we're going to do is we're going to start off with this that we know. We know that if we plug in X, Y, and Z, which is the point, we should get something in terms of A, B, C, and D. So this is what I mean, guys. I'm going to plug in, for each point, I'm going to plug in X, Y, and Z to the standard form of a line, or of a plane. So if I plug in 5 for X, I'm going to get 5A. If I plug in -1 for Y, I'm going to get -B. And if I plug in 2 for Z, I'm going to get 2C equals D. And I'm going to do this for every point. Okay, so that would give me, for the second one, it gives me -1A plus 4B minus C equals D. And then the last point would give me 2A plus 3B plus 6C equals D. Again, I'm plugging in X, Y, and Z, each of these points to this. So I get these 3 equations, and I'm actually going to number them, equation 1, 2, and 3, because I'm going to use them on the next page. Okay, so the problem with solving this, guys, is knowing the way that we've solved things in the past is we have to have as many unknowns as we do equations. And here we have 1, 2, 3, 4 unknowns, A, B, C, D, but only 3 equations. So this is what I was talking about up here, but I wanted you to see it first. So this situation where we have 4 unknowns but only 3 statements is called a system of Diophantine equations. And technically, there are an infinite number of solutions, which we know is true because we know that we have a bunch of different points on planes. And so we have to figure out a way to come up with the equation of the relationship between them. Okay, so we're going to start solving this as if we would solve this any other time, which is we're going to try to get things to cancel out. But what we don't want to do is get rid of the D value. So we do not want to eliminate D, but we're going to try to get all the other variables to cancel out and be in terms of D. So that's our plan. Okay, so looking at the system that we had back on this page, in fact, I'll copy it over for us. I'll copy the numbers too. So I'm going to have that here just for a reference, so I'll keep it off to the side. So if we want to start out just like we would any other time, so once we get our equations, we want to cancel out some variables. So it looks like we could eliminate either A or C pretty easily because of the fact that like this one is just a -1A, so I'm going to be able to cancel the A's, or the C is just a -1C. So again, I could cancel it. I'm going to go ahead and choose to do the A. So what does that mean? Well, that means I could add 1 with 2, but I would have to multiply 2 by 5. So that's what I'm going to do. So I'm going to multiply the second equation by a 5, which gives me a -5A. Be careful when doing this, guys, because one little mistake, one little thing that you don't multiply by a 5, and this is over. So take your time. So I multiplied everybody by a 5. negative 5, 20, negative 5, 5. Then I'm going to add, the a's cancel. So I end up with 19b minus 3c. Take your time. I'm actually going to write that again. And then I'm adding 60. Take your time. Okay, so now I've reduced it to just b's and c's. So I'm going to try to do that with two others. So I'm going to try to get the a to cancel out. So I'll use 2 and 3, but I'm going to have to multiply 2 by 2 and then add it with 3. So this guy times 2, again, take your time, negative 2a, 8b, negative 2c, 2d, and then 3 is the same. Okay, a's cancel. I get 11b plus 4c equals 3d. Okay, so once again, at this point, I have taken and gotten rid of all the a terms from both equations, which is great. So I've taken it down to 2 variables. I'm going to call this one equation 4. Since I already have 1, 2, and 3, I'll call this equation 4 and this equation 5, just so that we can talk about it. So now I need to get another one of the variables to cancel. So which variable do you think, B or C, would be easier to eliminate? Agreed. I think C is going to be the easier one. So that means I need to multiply equation 4 by 4 so that I get 12. And I'm going to multiply this one by 3. And again, they're already opposite signs, so that's good news. So then I'm going to do this guy by 4, which gives me 76b minus 12c equals 24d. Take your time on that. And then this guy times 3, so 33b plus 12c, which was the whole point, equals 90. People forget all the time to do this guy. Like, they forget to multiply that one by the 3. So just make sure everybody on both sides. All right, the c's are going to cancel. That was my whole point. And I get 109b equals 33d. Now you're almost there. You're very close. These next few steps are going to be a little weird, so hang with me. I'm going to solve. Remember, the whole point is we want to leave d in the problem. So I'm going to solve for whatever variable this is by dividing. So I get 33 over 109d. This is the first thing that I have discovered. I know what b is. I know it's in terms of d. It's not just like a number like 2, but that's a good thing. So now that we have one of the values, we're going to start using this value of b to go back and get one of our other values. So just like before, what you would normally do is you would take whatever you got for this and you would plug it back into one of these two equations, your previous step. And I think I picked to plug it into, let's see. Yeah, I picked to plug it into number 5. So take a look at what I'm going to do. So I'm going to take one of these equations and I'm going to plug the b back in. So this is the equation. This was equation 5. And I'm going to replace the b with the 39 over 109d. So see how I'm plugging that in. Now you might say to yourself, well, that's not helping, Meg. I still have, or Miss Thatcher, I still have 2 variables. Well, go with it. I'm going to multiply this part together. And I'm going to take it to the other side. So again, I did that pretty quick. So I had like 33 times 11. And so I ended up with, this was technically 363 over 109d plus 4c. I just want you to see each step. And then I'm going to subtract this. So I subtracted the 363, which means I changed these into common terms. So like technically I had 4c equals 3d minus 363 over 109d. So like to be able to put these together, I had to change this guy, or actually I just did in my calculator 3 minus 363 over 109 and then did math to frac. And I'm going to do that right now just to make sure. Math to frac that thing. So I got negative, this ends up being a negative 36 over 109. And then I divided, obviously, both sides by the 4. So I'll show you that real quick. So again, I plugged it back in. I brought all my d terms to one side. Technically I got negative 36 over 109. D equals 4c, and I have to solve for c. So I divided both sides by 4, or multiplied by 1/4. That's how I got this. Here's my second step. So here's my next variable that I know. Again, it's still in terms of D, but I know I have an expression for it. Last step would be to plug this into an equation that uses all three. So an equation that uses all three could be one of these, and you can pick any of them. I picked to use the most basic one, which is, I believe, equation 3. So think about it, what we're going to do. We're going to plug in our B value for B, which is in terms of D. I believe that B value, there it is. I'm going to plug this guy in. I'm going to plug in the C that I got. And I should only have A's and D's left. So let's see. So there I go. There's me. I'm plugging in. I plugged in the B value and multiplied by 4. So that gave me 132 over 109. I plugged in the C value, which was here, -9, and multiplied it by a -1. And then I've got that. Again, I'm going to do a little intermediate step. So then you could put these two together. This becomes plus a positive. So I end up with plus 141 over 109D equals, this side was just 1D. So then I'm going to have to subtract the 141 over 109. I'm going to bring all that together. This is 1, remember. So in my calculator, I'm doing literally 1 minus 141 over 109 and seeing what I get. And then math to frac that. So I got -32 over 109D, careful, equals -A. So I have to finish by dividing both sides by a negative, which would just make that guy a positive. So there you can see it written out. Okay, so now I have everybody, I have A, I have B, and I have C all in terms of D. So we are very close, right? What I'm going to do is plug those back in. So again, guys, remember the whole point is you're trying to find A, B, and C, A, B, C, and D. So you found A, B, and C all in terms of D. So that means that you can pick any D value that you want to finish this equation of the plane, guys, because now you can plug in any D that works. Like you can plug in D equals 1, you can plug in D equals 3. Any of them will get you an equation of a plane. Now, what is a smart D value to plug in? Hint, hint, we'd probably want to get rid of the fractions. So yeah, if we let D be 109, then this is going to come out nice. Look, because then we'd have 32 times 109. It's over 109. We'd have 33 times 109 over 109, right? You're always going to pick whatever's creating that denominator because then it'll cancel out that denominator. Remember, don't forget to plug in 109 here as well. So every D gets replaced with a 109. So I get 32x plus 33y minus 9z equals 109. There you go, guys. That's your equation of your plane. You just found it. Once we replaced all those values, you got the equation of the plane. If we could reduce, like let's say these were all divisible by 3, I would divide them all by 3 and get my most reduced version, but this is it. If you wanted to verify that this in fact was the equation of the plane, you could make sure that those 3 points work. So like here's me showing you me plugging in the first point. Yep, I get 109. Here's me showing you I plugged in the second point. I do in fact get out 109 and I get out 109. So you could always check to see if all 3 points give you 109. And they did. Okay, so that's how we do it. I mean, that's how we write the equation of a plane. The other thing is, if I did want to find, if I did want to take the equation of a plane and get the intercept, sometimes that's helpful. If we set our equation equal to 1, we have the intercepts. So that would be, if I took my original equation of my plane and I divided everybody by D, that would set it equal to 1, which is intercept form. So I would have, now remember, technically you have A over D, but I'm going to put that in the denominator, so that becomes D over A. The y-intercept becomes D over B, and the z-intercept becomes D over C. Again, that's me taking the numerator stuff down. So you can change it, and the nice thing about why would you want the intercepts? Well, because then you could graph it. So like, just to show you a quick example, let me use a nice one. If I had 5x minus 2y plus 6z equals 4. So if I divided everybody by 4, I would have x over 4/5 minus y over, technically this would be 4 over -2, so I could make it 4 over negative 2 is negative 2 on the bottom. And then this would be z over 4 over 6, or 2/3, equals 1. I divided everybody by the 4. So these are my intercepts. So that means it would be 4/5 for the x-intercept. It would be negative 2 for the y-intercept. And it would be 2/3 for the z-intercept. And again, that could just help you with graphing, because then you could quickly graph this plane. Like I could go 4/5 on the x-axis. I could go negative 2 on the y-axis. And I could go 2/3 on the z-axis, and then I'd have my little plane. So it can be helpful to do that once we have those values. Okay. So I figured you might want to try one on your own. So here's an example. I used PQ&R again. You try it. Try using that Diophantine. You can go back and watch it first if you want to again. The setup. Remember, we start initially by plugging everybody in and creating our 3 systems of equations. Okay. If you want to hit pause now, you can go ahead and hit pause. Otherwise, I'm going to start solving, so I suggest hitting pause and then coming back. Okay, so hopefully you've tried it. So the first thing I need to do is make my 3 equations by plugging in the points. So I get 5a plus 7b minus 2c equals d. There's my first equation. 3a minus b plus 4c equals d. And a plus 2b plus 3c equals d. Take your time. So make sure first that you have those equations correct. Okay, and then I'm going to choose a variable to eliminate, something that's easy. So anybody that has a coefficient of 1 would be easy. B is not bad and A is not bad. I guess this time, since I did A last time, I'll choose B. So I'm going to get the B's to eliminate. So if I add, let's see, if I add 1 with 2, that will cancel if I multiply 2 by a 7. So that's what I'm going to do. I'm going to multiply equation 2 by a 7. Take your time. Everybody on both sides gets multiplied by a 7. So 21, negative 7, 28, 7d. Be careful, that's the one people forget. Add these guys together. That cancels. That was the whole point. I get 26a plus 26c, ooh, interesting, equals 8d. You could simplify this if you wanted to, like reduce everybody by a 2. It's totally your choice. If you don't want to, that's fine. Okay, now I need to cancel b, but I need to use 2 other equations. So I'm going to use the second and the third equation, but I would have to multiply this guy by a 2. And then I can add it with 3. So this guy times 2 would be 6a, negative 2b, 8c, and 2d. Don't forget everybody on both sides. A, 2b, 3c, 2d. Oops, I'm sorry. See, I almost made a mistake. That last one should just be d. Be very careful. All right, so then we get 7a, the b's cancel. That was the whole point. 11c and 3d. Okay, so these are our 2 new equations that just have a's and c's. So if you want to call them 4 and 5 for reference, there you go. So now this one is a little trickier because the numbers aren't so nice. So you can get either A or C to cancel. It doesn't really matter. Again, I could reduce this, but one of the easiest things to do, if you don't see one immediately, is to just, I'm going to multiply, for example, 4 by 7, or I'm sorry, I'm going to take this equation times 7, which will get these 2 the same, and then I'll take this guy by 26. So as a last resource, you can always just basically multiply them by each other. And I'll have to do this one by a negative so that they cancel. Okay, so this one might take a second because I need to multiply everybody here by a 7. So I get 182a, 182c, and 56d. And then everybody here gets multiplied by, careful, a negative 26. So negative 26 times 11 gives me negative 286. And then 3 times negative 26 is negative 78. Be really careful. Those cancel. I have 182 minus 286. Heck yeah, I'm using my calculator, guys. You should be too. And then I have 56 minus 78. Okay, so I get negative 22. I'm going to divide D. Whoa. I'm going to divide both sides by that coefficient. So technically I have negative 22 over negative 104. I know that's going to simplify, so I'm going to do that. So that simplifies to 11 over 52d. Okay, at that point you have one of the variables. Pick one of these equations and plug that guy back in. I'm going to pick this one because it's smaller numbers. 7a, I'm plugging this in for c. So I get 7a, 121 over 52d equals 3d. So now I'm going to subtract the 121 over 52. So I have 3, I'm doing 3 minus 121 over 52. That's how much d I'm going to have on that side, equals 7a. So heck yeah, once again, I'm doing that in my calculator. I got 35 over 52d, but I have to remember to divide by 7. So I'm going to divide that by 7, and it actually reduces to 5 over 52d. Now I have the a value. Last but not least, you're going to go back to one of the originals. Oh, it doesn't actually matter which one. So you know what? I think I'm going to use the last one. I'm going to go back to one of the originals, and I'm going to plug in A and C and then get B because I need to get that last guy. Okay, so instead of an A, I now know that A is 5 over 52D. I don't know B yet. I know that 3 times C is now 11 over 52D, equals D. Okay, I'm going to solve this one for my last variable, which is B. So I'm going to put these two guys together. So I'm going to do 5 over 52 plus 3 times 11 over 52. And so on this side, let's see, my like terms actually ends up reducing to 19 over 26 because the 52s must have reduced, plus 2b equals d. I'm going to subtract this from both sides. Remember, this is a 1, so I'm going to do 1 minus that. So I get 7 over 26d equals 2b. And then my final step would be divide by 2, which would put it back over 52, which I kind of expected would happen. Okay, now what do you do once you have A, B, C, and D? Remember, the whole point of getting these guys was to get the coefficients for your plane. So now you're going to plug in your coefficients. 5 over 52d x. The coefficient on y is your b value, 7 over 52d y. And your c coefficient is 11 over 52 d c. Z, excuse me. And then this, don't forget the D on this side. So what D are you going to choose to plug in? Well, the one that gets rid of the fractions. So I would plug in 52. So if you plug in a 52 here, you just get 5x. If you plug in a 52 here, you get 7y. If you plug in a 52 here, you get 11. And if you plug in 52 here, obviously, you get 52. Boom. There's your equation for your plane that goes through all 3 of those points. You could plug each point in and just make sure it gives you 52. But it does in fact do that. Again, if you had trouble with this, maybe start fresh and try it again. That's my suggestion. But the biggest thing here, the biggest mistake people make is that they forget a negative or they multiply something wrong. So it's just really being meticulous. This is a meticulous. It's not hard. It's just being meticulous. You have a worksheet. It's called Worksheet 1 that's going to give you some of these problems. And some of them are nice because some of the points are 1, 0, 2. So maybe one of your variables doesn't show up, and so that's a little easier to eliminate. Anyway, so enjoy doing that worksheet, and we'll make sure that we get the answers for you and do some of those examples hopefully in class together.